Hello all, I am Catherine Meyer. Welcome to my video presentation on the impact of urbanization on peak annual stream flow. So urbanization and peak annual stream flow. Urbanization obviously is the increase of land that is being used as in an urban way, develops land in an area. And peak annual stream flow is the largest volume that has gone through a stream at a given time in the past year. Oh, sorry, guys. There we go. So there's several issues with urbanization and stream flow. There can be an increase in stream flow due to an increase in impervious area. So impervious area is anything like a roof or a parking lot or any place where rainwater doesn't soak into the ground. So impervious area can be an issue because instead of the rain soaking into the ground, it can all collect and go into streams or into storm sewers. If it goes straight into streams, that can lead to increased erosion and downcutting, which can destabilize banks. It also can wash a lot more pollutants into streams. All the cigarette butts and trash that are in a parking lot get carried right along with the water. In some areas, like in Cleveland in Ohio, we have an additional issue where we have a combined sewer, which means we have sewage and stormwater flowing together. Now, when this was originally done, it was a really good idea because the water off the streets was really dirty. They didn't want to send it straight into streams during storm events, so they sent it to the wastewater treatment plant. Problem is, our wastewater treatment plants do not have an infinite capacity. So now, as there's more and more impervious area, more and more of the water in the storm sewers was being sent to the wastewater treatment plants. And it's a bad day if we wash out the wastewater treatment plants. So they had to add in these places. A lot of times they look like this, where during just normal dry weather, okay, here's our sewage coming down here. But if we get too much storm water and there's too much here, it'll overtop this dam, and the combined sewage and stormwater will go out to the river or Lake Erie or what have you. So those are some of the issues with urbanization and streams, but this project is looking specifically at how urbanization impacts the peak stream flow in an area. So we're going to go ahead and talk about the data I used first off. So I used several data sources for this project. Sorry, things in the way there. So first off, I used some land coverage data or land cover data from the Multi-Resolution Land Characteristics Consortium. Pretty much it's just what is the land used for in all of the continental US is the data I used. Well, I specifically used it for Ohio, but I downloaded it for all of the continental US for 2016, 2011, 2006, and 2001. So 4 different years over a 20-year period. I also used peak stream flows that I got from the USGS Stream Gauge Network. I just selected Ohio and then was able to get 25 different stream gauges that had the peak flow data for the 4 years that I selected all across Ohio. And then I used stream stats to get the watershed of each of those stream gauges. So what area does the stream gauge drain? So stream stats is a really cool little program from the USGS where you can go to an area and these triangles, a lot of them are actually stream gauges, but you can zoom in and find a stream. Once you see these blue squares, you can do the things. If you hit delineate, you can click any point along this stream and it will delineate the basin for that stream or the area that that point in the stream is draining. So the entire area that it calculates, all the water in that area that falls in that area as rainwater goes through that point. So I did this for each of my 25 stream gauge locations so I would know what area was actually impacting those. So this is kind of a small one in the grand scheme of things. I was in a little stream here, but it's kind of cool. Then you can download it as a shape file. So that's what I did. So in ArcGIS Pro, I have all my stream gauge locations, as you can see. And what I wanted to do was have the watershed for each of those locations, and then use that to clip my land use layer for each location, and then be able to calculate what % of that watershed was urban for each of the 4 years that I was studying. So see locations, and then I have like up here, I had my big old watershed layer, which I then clipped to this area. Since it was a raster, I went ahead and converted it to polygons so that I could just look at the shape area of each polygon. Look at this attribute table quick. You see we have some that are developed. Those are the ones that I counted as urban. So anything like deciduous forest, obviously I didn't count as urban. And then I just looked at the shape area of developed areas out of the total area of all of those polygons to determine the % of each watershed that was urban by area. But I would have had to do all of this 100 times because I have 25 locations and 4 years. And I didn't really want to do that. So I wrote this script, and I'm going to go ahead and walk you guys through it quick. Top, I import ArcPy, which is just a module for interacting with data in ArcGIS Pro or ArcMap. And I import CSV so that I can export my data to a CSV. I open up my CSV here, and then this is a function I'll explain in a minute. But I go down here and I say my feature class is this, which was my location data. And the fields I want to use are whether it's one that I marked as usable or not, and its site number. So I go through that layer, and for each row, as long as I said it's usable, I would get the ID number of the row, and I would find the % urban, the % area of the watershed that was urban for each of these years. And so that all happens in this function up here, where first off, I have the original raster, which I knew what the name of them all was the same except the year. So that's why I had to input the year to this function. And then I have my output raster, which I just named something based on the year and the ID number. Then I had my watershed layer. So all the watershed shape files that I downloaded from StreamStats were in a folder identified by their ID number. So that's why I had to pull in the site number as the ID number so I could find the watershed shape file that was associated with that. So then I just clip the land use raster by the watershed shape file and create my output raster. And then I convert my output raster to a polygon. So then I have, this is my new feature class, my polygons. And I'm going through the shape area fields, and I'm also looking at the NLCD land cover class fields. So as I go through that, I'm looking, and if developed is in the class field, like the ones I showed you, then it adds the shape area to the total developed. And regardless, it adds the shape area to just the total. So then it outputs the ID number, the year, the total area, and the total developed area to an Excel spreadsheet where I was able to do the % calculation pretty easily to determine the % of each watershed that was considered urban area. So then I got back in Pro and joined that to my data. So I'd have my percent urban along with my peak flow, that's in cubic feet per second, and my year for each of the different sites. You'll see I have this site here a few times because it's for different years. And so I've got all that data. Cool. So then I made a chart of it to see if the correlation was there, because what I wanted to see was, as the percent urban area goes up, does the percent or does the peak flow go up overall? Unfortunately, as you can see, that was not the case. So here's a chart of that. My R squared is 0. So there was literally no correlation between those two things. You'll see we did have a decent, well, a better correlation between urban area and watershed area, but that's because as the watershed gets bigger, so does the amount of urban area in it, typically. Next highest correlation was watershed area with the peak flow, and that's because a larger watershed is going to collect more rainwater. So that's to be expected, although we might have expected the R squared value for that to be higher. And because the urban area and the watershed area are correlated, there's also a slightly higher correlation with that and the peak flow there. So as we could see, no correlation between peak flow of a stream and the percent of its watershed that's urban. So my hypothesis was not supported by the data. I think probably the issue with this is that there was a lack of change in the percent urban area during the study period. So most places had a maximum like 2% change in percent urban area in their watershed. I think if you did this study over a longer period of time, you might have slightly better results. And then watershed versus urban area. We discussed that. Obviously, the watershed gets bigger, it's likely to have more urban area in it. The outliers are most likely like Western, Southeastern Ohio, just less developed areas in the state. Probably these high outliers are probably up in Cleveland or around Columbus, Cincinnati, one of those more developed areas. And also, well, we talked about urban area and peak flow. Okay. So other than that, I looked at all the data in this aggregated manner. I also looked at the data just per watershed. I went ahead and did that in Excel. Here's some examples of the sorts of charts I was getting. So that's the ID number of each of these. It's just the percent urban down here. You'll see it didn't increase that much, like 0.4%. And the peak flow over here. You'll see some of them are going up, some of them are going down. This is just a small sampling, but this one is closer to flat. None of them have a very high R square value, except this one. This one was a little bit more decent, but for the most part, they're like 0.2 or lower, 0.3 or lower. So overall, it didn't look any better in the individual results than it did in the aggregated results. It was a little unfortunate. One of the potential problems for this study was that some years have larger storm events than others. And because I was just looking at the peak flow for the year, weather patterns were not really taken into account. Ideally, you'd want to look at several storm events in a year, possibly normalize that data. But between data availability, computing power, and just amount of time I didn't have time to do that in this study. But any future studies would definitely benefit from taking that into account. So overall, my study did not show a correlation between peak flow volume and urbanization, but I think it would give better results if weather patterns were considered and if it was done over a longer period of time, or potentially in an area with a larger urban areas than Ohio. Ohio is just not known for its urban areas. So thanks for checking out my video, guys. and I hope that you have a lovely day.